In this video, we are demonstrating our constraint analysis and solution techniques at the example of an interactive constraint modeling system. Here is the problem. We are given a 3D model with constraints. In this simple case, green edges are constrained to be horizontal, orange edges to be vertical. Furthermore, the footprint of the building is supposed to be a rectangle. Now consider the simple problem of moving a single vertex. Clearly, to satisfy all constraints, other vertices have to be adjusted too. However, when optimizing all vertices with the additional constraint that they stay as close to their original position as possible, the complete model changes in an unexpected way. The constraint analysis method we are proposing finds a minimal set of vertices such that all constraints can be fulfilled, while at the same time the model changes as little as possible. Here is a more realistic example. Our constraint analysis and solution technique is integrated into an image-based modeling system. The system is based on the construction of a skeleton-like structure only. The actual mesh is generated by a volumetric CSG approach. In this case, the vertices of the dormers are constrained to be coplanar with the roof. When the roof changes, the dormers have to be adjusted as well. The number of vertices selected by our approach is small. However, the resulting editing operation may not be what the user expects. A simple way of interacting with the constraint analysis approach is to manually fix vertices. The new solution consists of more adjusted vertices but feels more natural. The dormers are constrained to be symmetric and identical. Therefore, changing a single one changes all of them. In this example, all edges are constrained to keep their length. Our constraint analysis determines the set of vertices to be adjusted for infinitesimal editing operations. The result therefore is only correct until the two edges reach their maximal extent. However, this can easily be fixed by automatically adding constraints and rerunning the analysis each time one of the existing constraints cannot be satisfied anymore. This way it is possible to interactively unfold the structure as expected. In the following, we give a quick tour of our interactive image-based editing system. Facets are created by drawing strokes into one of the input images. The initial supporting plane is recovered from automatically reconstructed 3D lines. Precise alignment with the images is performed by fitting the edges of the model to 2D lines in the input images. Vertices can be explicitly snapped to existing geometry, and constraints like orthogonality, as in this case, are added manually. We can furthermore add symmetric elements and clone groups of facets. As already noted, the final mesh is constructed by a volumetric CSG approach in a binary space partition. Thanks for watching.